Alrighty, so questions up front. Yes.
Does 4 double-sided notes imply we can bring 8 single-sided pages?
Correct. Or you can bring 2 double-sided and 4 single-sided, or any combination.
Is that a 1 hour final?
2 hour final, hour and 50 minutes.
Two
How many
two
problems do we
lectures
have?
together?
So
Both lectures combined together?
no, there's a final for A and a final for B. Maybe I don't understand your question.
Oh, when's the final for 8?
It's on
Should
Monday
be
at
Monday
10.
at 10 o'clock till 11:50.
On Monday.
Yeah,
It's in here, right?
it's in here. And the final for section B would be Wednesday from 11 o'clock till 12:50. And then the 2:15 final is Monday from 12 o'clock to 1:50. So every final is basically 2 hours.
I think Portuguese CD says 10 o'clock. Not sure.
Yeah, let's check Canvas anyway, because
And it says December 10 to 12 p.m.
yeah, 12 p.m.
Oh,
Yeah.
actually. Okay.
Yeah, 10th is Monday, right? Friday. Yes. Okay. So Monday at noon is 2:15. Monday at 10 is 2:24.
Our question, our exam, for example, when's the section B be harder than section A? Since we got 2 more days to study.
You have 2 more days to study. This is true. No. No, they should be comparable. They're not the same exam, but I tried to basically, ask the same types of things. So I wouldn't try to do that kind of calculus and figure out which one to take. But I am going to ask that people who take the A exam don't talk about it until after Wednesday. Okay? Just because that could give an unfair advantage to people. Just kind of like where my brain was, the kinds of things that I was asking. But I mean, it's similar to the midterm in some ways. I mean, programming questions in Bash, programming questions in C, short answer. There's going to be a lot more short answer. There's going to be 50 points worth of Unix-related questions, fill in the blank kind of things. And then 50 points of programming.
So it's going to cover the whole quarter also?
Yes. So let's look at the study guide.
What are anchors, since we're on the subject?
So anchors are when you do a regular expression, a caret and a $sign.
Oh, those are
So
anchors.
if you search for a caret period, it means I want a period, but it's got to be in the beginning of the, right? So it's sort of anchoring the rest of the pattern to one end or the other of the input line.
So the caret and the $sign are anchors?
Yeah, in this context.
Are there going to be regular expression questions?
Sure, why not?
Because you don't like grading them.
I don't like grading them, but they're good to know, so I want to test on them.
And obviously, Aachen said and are on the list.
Aachen said are fair game, yeah. Nothing too crazy with Aachen said though. Right, just sort of the basics. I mean, we can just run through this from the beginning, but if there's questions, keep them coming.
What type of questions are there going to be, like fill in the blank, multiple choice, and long ones as well?
So 5 programming questions, which will be longish, right? And then the other half will be short answer, right? Show me a Unix command, show me a line of code, tell me what this call to fork would return, you know, short answer kind of stuff. I don't know if I had any multiple choice. I might have a few, but those are all kind of lumped together. But it'll be different from the midterm in that way, because 50% of it will be Linux questions, basically. So, so what do you want to know about Linux? All the basic commands that hopefully you've been using throughout the quarter, right? So, echo, you know what that does. The print statement, basically. Cat, which shows you the contents of a file. Copy, which copies a file. Move, which renames a file. RM, removes a file. LS lists files. OD shows you the contents of a file in a different format, typically octal or hex or characters. WC tells you how many words and lines and characters are in a file, and so on and so forth. Most commands will take a file name, so cat will take the name of a file and will show you the contents of the file. Right, so if I say cat test, shows me the content, well, test is the directory. Alright, so bash rc shows me the contents of that. But if you don't specify a file, it defaults to reading from standard in. Right, this is standard Unix behavior. So this is standard in. And a lot of commands do that kind of thing. So standard in, standard out, standard error are your three default streams, right? Standard in is usually your keyboard, but if you do a redirection, right, then standard in comes from the contents of that file. And if you do a pipe, then standard in to command will be whatever the output of C1 is. Right, so there's a test file. I can say cat test file, and it reads from that. If I say cat without any arguments, like I just said, it's going to read from standard in. But if I say cat and I redirect from test file, standard in is coming from test file, so this reads the contents of test file. If I cat test file and I pipe that into cat, then cat is going to read standard in from the output of that command on the left, which is just the contents of test file, and so that's just test file again. Alright, so you can have a whole line of cats. So standard in is yes?
Oh, finish your standard in, go on in the previous direction.
Oh, go ahead.
Okay, so for the long-term programming questions, for the midterm, we had all the ODPs to look through, we had a series of, built-up programs, but then since the midterm, we kind of haven't had very many ODPs at all, and then the only two big programs we've done since then were Program 4 and then the Zenity thing, which was not very algorithm-based. So. Right,
but PA4 was algorithm-based, right?
Yeah, it was a good care one. So should we just kind of focus in for in terms of the long term, what would be added on in terms of programming concepts?
No, it's going to be similar to midterm questions.
Okay.
So I would still go back through the ODPs and the earlier programming assignments, but also think about PA4 maybe.
Okay.
Right? But yeah, PA5 didn't really have a whole lot of algorithm to it, so probably not a whole lot of study value there for the programming questions, but there could be a Zenity question or two. So.
What are we going to have in terms of sed and awk? What sort of questions?
Oh, questions where you provide the answers. So what do sed and awk do? So sed lets us pull out lines from an input stream, right? So show me a sed program to print out every line that's at least 4 characters long, right? So how would you do that?
4 periods?
Yeah, so if we just search for ... right, this would match any line that has at least 4 characters in it. So you could say sed, and then your pattern might be / ... slash, and then we could say print. And you'd probably do a -n to like stop the automatic echo. So stuff like that. Awk basically works with fields on an individual line. So show me an awk program to switch the first and second words on a line, where words are things separated by spaces. So right, so that would print out the second word followed by the first word with a space in between. So sed, we have a pattern that we're looking for and we have commands. Awk, we can put in a range of lines and we can print out fields and stuff like that. Now there's other stuff we did with awk and sed with associative arrays and things like that. I'm not going to get really hairy on you. Okay, so kind of stick with the basics. But probably either writing some awk and sed commands like that, or maybe looking at an awk and sed command and saying, what does this do? Right, or what would be output by this if this was the input file? All right, so standard in, we said standard out is basically where output goes, and it's normally your display, but you can redirect it into a file, or you can pipe it into another command standard in. Standard error is like standard out, but it's a slightly different stream, so you can force things to standard error, and then if you do a redirection like this, right, this is redirecting standard out, but not standard error. So standard error output will still show up on your screen, but things from a regular printf will go into your file. With Zenity, when we were doing this, we were redirecting standard error as well. So using greater or less than to redirect output and input. I don't know if we actually played with this, but if you do this, that says append to a file. So if I do this a bunch of times, right, I've got whatever the latest date was. If I do this, it keeps adding to the bottom of the file. So it's an append. That can be useful. Probably could have been useful for PA5. All right, and pipe lets us connect commands. Standard out of one command becomes standard in of another, so we've said that a few times already. Quotation marks, so single quotes, double quotes, back quotes. So quotation marks in general group things together, right? All right, so I'm just echoing $1 and $2, right, from a bash script. So if I run this and I say hello, bye, the first argument is hello, the second argument is goodbye. Right, same thing there. So if I put these two things in quotation marks, right, that becomes a single argument. That's one of the reasons for using quotes. So it groups them together, so that's all one. And if I were to like put the whole thing in quotation marks, that's all the first argument and there is no second argument. Okay, and that's the same whether we do single quotes or double quotes.
It's gonna be same.
Is what?
It's the same thing.
It's the same thing in terms of saying, don't pay attention to the spaces in here. Don't use that to break this up into different arguments. Treat this all as one thing. But the difference is that if we're inside double quotes and we have something like $ variable, that'll get expanded, right? So, so let's just echo x equals $x. Or let's just do x equals $x in haha. So my first argument is x equals haha, right? So the shell takes the $x and actually replaces it with the value of x. And this was as if I had said haha, x equals ha ha ha.
So the haha is gonna be changed to high capital.
Yeah, that's just because I set x to be uppercase.
Yeah.
But if you do this with single quotes,
Oh.
right, then the $sign is just a $sign x is just $x. So that's the big difference between double and single quotes. Right, with double quotes, this will get replaced by the value of the variable. With single quotes, it's just another set of symbols. And then back quotes, execute a command, capture standard out, and use that as the value of the back quoted expression. And you've been doing this a number of ways. Right, so the classic would be x equals back quote date. If I look at the value of x, it's the result of the date command. If I say x equals regular quote date, then x is just the word date. And same thing with double quotes. Right, and if I said x equal to single quote back quote date, right, those back quotes are not treated as magic, they're just another character, so x is equal to back quote date. If I said x equal to double quote back quote date, x is equal to the output of the date command. So double quotes let things still be interpreted in an interesting way. Single quotes really just make it literal. All right, so shells shells program that runs and picks up commands usually from the user and does things and then comes back and waits for more commands. That's a horrible definition of a shell, but it works. The shell we've been working with exclusively, and here's the bash shell, or bash, the born again shell. And .bash rc is this file that gets executed when you start bash. Right, so see if I saved my connection. I did. Right, so in my bash rc, if I put an echo statement at the end of it, then every time I log into my bash shell, I get my little echo statement, right? So we use this to do things that we want to do every time we log in. Like, for example, I wanted to set my prompt to look this particular way, right? So it's the command expression with curly brackets around, so I know I'm on the Linux server instead of my laptop. I wanted to set up QA to be an abbreviation for this. I wanted to say, don't ignore my control Ds, right? And different stuff like that. So all of these commands are executed every time that I hop onto the Linux server, right, rather than having to type them. there's an awk command I use to look at your source code after you submit things through an ODP. I don't know what the heck that does anymore. It's easy to write. But when you submit through the assess command, right, there's a bunch of information that gets logged, including your source code, and I start your source code with a 1 followed by equal signs, and I end with a 0 followed by equal signs. So this is just an awk script that basically pulls those things out and shows me the source code. So if everybody's struggling with an ODP, I can just say extract, and it'll rapid fire show me all the source code, and I can see, oh, everybody's doing this, you know, because I forgot to tell them about something. So all this stuff, right? So that's what your bash RC does. And then the shebang, right? So in the very beginning of a script, you can say $! exclamation mark, and then put in the path to a shell, which for us is /bin/bash. And it says if I just type the name of this file, here's what we should use to execute it. And if you're someone who adds comments at the very last minute before you submit something, make sure you add them after the bin bash. Right, that's got to be the first line of the file. And then your comment block can come after that. But if that comes after your comment block, it's ignored, it's just a comment. And then if someone in a different shell tries to run your script, it'll use whatever shell they're using, and your code likely won't work. So we put this in to make sure that if you're running a different shell, when you run somebody's script, it still uses bash in this case. All right, so processes. Right, so if you put an ampersand after a command, it says run this command, but run it in the background. So I immediately come back and I get a prompt from bash, and I can do whatever I want here. I can say PS, and so on, and this command is in the background. Cat happens to be waiting for input, so it's put it into a stopped state because it's not going to do anything until I give it some input. And I can bring it to the foreground, and now I'm running the cat command again. And I can type stuff in. I can hit Control-Z to stop it, and I can hit BG to say go ahead and run in the background. And I can say 4G. And I can kill it by saying kill job 1, and it terminates my cat. So there's these different ways you can manipulate jobs through bash, right? Mostly you run a job, it's in the foreground by default. If you do a Control-Z, it suspends it. If you say BG, it puts it in the background. If you say FG, it brings it back to the foreground. And if you run your command with an ampersand, it starts off by running in the background. And you can have multiple jobs. And if you say jobs, you'll see all of your jobs that are running. And I've got 5 jobs running in the background. They all show up under PS. I can bring one of them to the foreground, like foreground %3. And now this is in the foreground. Bash is not listening to my input. Control-C will kill it if I do a jobs. Job 3 is not out there anymore, but the other ones still are. And you can kill them or let them die. I'll just let them die. All right, so what about fork? What does fork do?
It clones.
It clones.
And bring out twice.
Yeah. So fork creates a clone of your current process, a copy of your current process. And when you get back from fork, now you got 2 versions of your code running, right? So what does fork return?
The parent always 0 and the other one's the process ID?
Other way around.
Okay.
Yeah. So because the original process that's calling fork needs to know how to get a hold of the child process. Well, I guess you could do it the other way too. That's just convention. So yeah, the parent, the original process, gets the process ID of the child. The child gets a 0. So I guess the parent has more knowledge than the child. Maybe that's the motivation. And so this lets you create multiple processes. We talked about exec and popen and dupe2 and all that kind of stuff. I'm not going to ask you about those. Okay, but I do want you to know about fork. Execute fork creates a second process. Now you have two parallel processes running. Do they actually run at the same time?
If you have multiple cores, maybe?
Yeah, it actually depends on your hardware. If you have a single CPU with a single core, they don't execute at the same time. They take turns, like every other process on the system. Bam, 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 bam. But since there's, multiple processes, it's like boom, 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 boom. So that's what we call round robin. If you have two cores, you may actually have both streams executing simultaneously. But it also depends what they're doing. If they both need a resource and there's only one resource, then one will take some time and then the other, and so on.
If you nestle a fork thing, how would the order go in that?
If you nested it,
Like if you had one fork and one fork had another fork, how would the order of operations go on a single core?
it'll just, so basically it time slices. So if you've got, 10 processes that are trying to run at the same time, each one gets a little snippet of time and it just alternates from one to the next, and then goes back to the beginning. And you can do things. Oh, my sleep's died. There's this field when you do a PS priority, and I believe the lower the number, the higher the priority, which always seemed backwards. But these things with -40, those are very high priority jobs. And so a job with higher priority that wants the CPU will take precedence over one with a lower priority, but you can have all kinds of different scheduling algorithms. You can give one process twice as much time, or you can just give all the time to the highest priority. And there's a whole science/art to that. All right, file systems. So dot is your current directory, dot is your parent directory. And these are useful for accessing things in different parts of a file system. Right, so PWD shows you where you are in the file system, so I'm several levels down from the original /, which is the root. If I do an ls, I can see what's in my PA5 directory. If I say ls ... I'll see what's in the programming assignments directory. If I say ls ... /PA1, I'll see what's in the directory if I move up one level and then come down through PA1. Right, so this is just a hierarchy.
So dot is the directory before it? Directory?
Dot is the directory above you, yeah. So before in that list. So if I'm sitting right here, this is dot. This is dot. This would be dot /. Right, go up one directory, and then go up one directory. And if this is a directory called A, then this would be dot /A. But that's all relative to where I started, which was right here. Right, if I started off over here, then this would be dot would take me here, dot /. would take me here, and so on. So these kinds of things are called relative file paths, right? And similarly, if I'm sitting here, and let's say this directory is called X, if I'm in here and I just say CD to X, it's going to move me into this spot right here. But maybe over here I've got a directory called X, and if I happen to be sitting here and I say CDX, it's going to drop me into here. So this is not an absolute path. It doesn't always point to the same directory. It depends where I am when I use this path name. Right, so that's another example of a relative path. An absolute path is one that starts with a slash typically. Because slash means that, we're at the very root of the tree. When I say slash home, slash Nick, it's saying go to the top of the file hierarchy, move down to home, and then from there move down to Nick. So this is an absolute path. So ls/home shows me what's in my home directory. If I say ls/home, I'm looking for a home directory inside my current directory, and that doesn't exist. So I don't think I asked you about relative and absolute path names on the exam, but it's something that will come up sometime, so I just wanted to mention that. So hidden files are what?
Files with a dot in front of them.
Yeah, files that have a dot in front of them.
Like this SWP file you create from B.
Yeah. Right, so if I do an ls, I don't see my dot haha. If I do an ls-all, I see that I have a file dot haha. And ls just doesn't show you things that begin with a period by default. So it lets you have files that you want to have in your directory, but you don't want to burden the user with having to see them every time. And yeah, when you're editing a file, you get a .haha.swap or .filename.swap file, which tells it that you're in the process of editing this file. And then you get your annoying messages. File permissions. So, that's a generous directory. So those RWX, right, tell you the things that people can do to this file. And they come in groups of 3. So this is the owner of the file, this is the group of the file, and this is everybody else. And you have read, write, and execute permissions that you can give or take away. And change mod lets us set or clear these bits by using a 3-digit octal code on the file name. And this is persistent. Right, so by default, my text file comes out with a 664 permission. If this was a script that I wanted to execute, what's our usual permission that we give? Yeah, 755. Which changes it to where I can read, write, and execute. Everybody else can read and execute. And that's a property of the file just like its name, right? So I can edit haha. And that's not going to change these permission bits. Okay, this is why you only have to do this once per file. If I delete this file and I create a new version of haha from scratch, it's going to go back to a 644. And then I have to do the change mod command. But this by itself is persistent. If I copy it into another file, that other file inherits its permission bits. right? So there's nothing wrong with doing this, right, as many times as you like, but it doesn't do anything, right, if that's already what the permission bits are. So I've seen some people doing that every time they want to run their program. You don't have to. All right, what about symbolic links? Do you remember those? All right, so I've got one file in my directory. It's called old file. I want to create a symbolic link to it. So ln is the link command. -s says make a symbolic link. And then the file that we want to link to. And then the file that we're actually creating, which is going to be a link. And now if I do an ls, I've got this file called new link, and it's a reference to that old file. So if I cat new link, it's got the contents of the old file. If I vi new link, and I look at old file, the old file has the changes that I just made to new link, right? Because new link is referring to that old file. If I delete old file, new link is still there. But if I try to look at its contents, it tells me there's no such file, right? And it's not that new link doesn't exist, it's that new link is a pointer to old file, and old file doesn't exist. Right, so now if I create an old file, and I look at new link, it's whatever's inside old file. Won't let you make a link to yourself. All right, so there's also hard links, and we touched on those. I'm not going to ask you about hard links because they don't get used very often, so, but you should know how to use symbolic links. And so as we're going through this, right, if these things are surprising, or you haven't heard them before, or you vaguely remember them, but you're not sure what's going on, right? Mess around with them. You got tons of days between now and the exam, and I know you got stuff to do, but spend some time playing with these. Write a C program and call fork, and look at its return value, and it'll jog your memory, right? And if it's not jogging your memory, and you're like, I really don't know what's going on here, right? Ask me. Yeah.
If you if you had an infinite loop that all you did was call for it,
Yeah.
but then destroy your system pretty
Yeah.
quick,
Very quickly.
okay.
Yeah. Doesn't even have to be infinite. I think if you called fork 100 times, that would probably do it. Because each time that you go through there, it will double the number of processes. So that would be 2 to the 100th processes. Yeah, so that's pretty quick. Depending on how your system's set up, it may have something which says, you're only allowed to have 6 processes, and then your subsequent calls to fork would fail. Or it may just use up every available process slot. And that's a real drag, because then it wants to fire off a process to handle the error, and it can't because there's no process slots available. And it may just hang, and it may periodically let you get through a command. It's kind of like when you fill up your disk, right? There's things that you can do, and there's most things that you can't do. But you can pop into a VirtualBox Linux and play with that pretty safely, I think. All right, setting variables, we've done this a bunch, but I think the main thing that you want to know is this is just the letter X. This is the value of the variable X, right? And this is just 3 characters, 2 plus sign 3. This is saying take 2 and 3, add them together. This will be equivalent to 5. So if you want to take x and y and add them together, do this.
What's the purpose of a symbolic link?
It's like a shortcut in Windows. It's a way to have one file refer to another.
That's basically how we use it.
Effectively, yeah. So
Or use it.
So when I say Java, it finds Java inside user/bin. But if I look at user bin Java, it's actually a link to user local Java 7, blah, 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 blah. Right? Because Java 8 was giving me some problems, so I made a link so that Java now actually points to this other file. Otherwise, I would have to type this in every time that I wanted to run Java, which is a drag, right? Or make a copy of this and call it Java, right? So it's a way to have something point to something else. That's probably the most common use. There's other reasons you might use it. All right, so evaluation of expressions, right? Plain old expression, 3 characters. That's really all you need to know about it. Exporting variables. So remember this. Right, so if I run my Go script, which should show me the value of $x, even though $x is hello, when I say go, it tells me that $x doesn't have a value. Right? Because when you have variables, they're local to your current bash shell. When I say go, that's a new process. It starts with a clean slate. So if I say export x, when I create this new process, it starts with a clean slate, except for things that I export. So it will know about the value of x, and so now Go will tell me, oh yeah, x is equal to hello. So it lets you basically make something kind of like a global. And we had to do that with Zenity. Built-in variables, so $123 show you the first, second, third arguments to your script. Okay, and the first argument starts with $1. $number tells you how many of these $123s you have, right? So if you say script, this is fun, $number is equal to 3. Okay, $1 is this, 2 is, 3 is fun. And it's slightly different from argc, argv. Right? Argc also counts the command as one of those arguments. So if you say C program, this is fun, argc is going to be 4. Because it's saying you got 4 arguments. You got the program name, you got this is fun. So put it on your notes because it's confusing. $* is the list of all arguments separated by spaces. $question mark is the return from the previous instruction. And $sign is your process ID. Right. Zenity you know all about, right? So I would say know how to use the entry, the calendar, and the info switches. Those are good basic dialogues to be able to work with. And the idea that Zenity, if you say -calendar or -entry, the user can supply some information, and whatever they typed in, that's the output value from Zenity. So if you want to capture that, usually put it inside back quotes, assign it to something. All right, where are we doing here? All right, so we'll I mean, you know GCC. We'll run through GDB, make files, tar files, regular expressions, set and awk. And then the rest is just programming. And I think this is, the bash programming is the same as it was on the midterm. C programming, I added in a few things. Some of these C types, is space, to upper, and so on. And some of the file I/O stuff. F open, F close. And I think the rest of it's the same as it was on the midterm study guide. So we'll run through the rest of that tomorrow. And again, bring questions.